When we solve absolute value inequality statements, we're going to be asked to represent our solutions in interval notation and to graph those solutions on a number line. So we need to make sure that we understand the relationship between inequality statements and interval notation, and how both of those can be represented on a number line. So we're going to look at a few different examples here to work on introducing or hopefully reviewing some of these different notations. So if we were to take a statement like x is greater than 2, that would mean x can be any number larger than 2. So 250, 3 is larger than 2, 2.1 is larger than 2, 2.0001 is larger than 2. So any value that we can choose that would be larger than 2 would be a solution to this statement. And we can represent that idea on a number line by placing an open circle, so an unfilled in circle, at x equals 2, and then shading or highlighting, somehow indicating all values to the right of 2, meaning that all values to the right would be values that would make that original inequality statement true. We use that open circle at 2 to indicate that 2 itself wouldn't be a solution. Since this is a strict inequality, the statement 2 is greater than 2 would not be a true statement, so we want to make sure that that value is not included as part of that solution. We can also represent that same idea using interval notation, where we list the largest and smallest value, in the other order, the smallest to largest value that would be solutions to our inequality statement. So since we want to represent all values 2 or larger, we would say 2, comma, all the way up to infinity, since we don't have an upper bound. Anytime we have infinity or negative infinity in our interval notation, we always use a rounded parenthesis. But then anytime we have an actual number, we want to think about whether this should be a rounded parenthesis or a closed bracket. Those ideas are all related to our inequality statement and are the circle that we use, in this case, that open circle. What we want to do in this case is use a rounded parenthesis, which indicates that 2 is not included as part of that solution, but all values, even values that are just slightly larger than 2, would be values that would make this inequality statement true. So saying that x is greater than 2 would be the same thing as the interval notation 2 to infinity with a rounded parenthesis at 2, or this number line representation where we're shading all values to the right of positive 2 and using an open circle at 2 to indicate that that value is not included. If we were to consider a statement like x is less than or equal to 2, this is very similar to what we considered before, but now we have that bar under our inequality sign that means or equal to, meaning 2 would be a solution to this inequality statement. We can set up another number line to visually represent what this solution means. So in this case, we would start at 2, but we would want a filled in circle since 2 itself would be a solution to this inequality statement. 2 is less than or equal to 2 itself. Since we have a less than statement, we would want to highlight or indicate all values that are smaller than 2. Since any value less than 2, for instance 0, -1, -300, all of those values would be less than or equal to 2. And then we could translate this into interval notation. Our smallest possible value would be negative infinity, since our arrow is pointing off to the left. And then we would want comma 2 with a closed bracket, a square bracket, on the right hand side of that interval notation. So this square bracket means the same thing as this filled in circle and the fact that we have that or equal to statement as part of our inequality. it means that if we take that value of 2 and substitute it into this inequality, it would make that statement true. Whereas again, in our previous example, we had the rounded parenthesis at 2, because if we plug 2 into this inequality, it would make that statement false. So if we have a strict inequality, we want an open circle and a rounded parenthesis. If we have that or equal to as part of our inequality statement, then we want a filled in circle and a square bracket. Anytime we have an infinity sign, whether it's negative or positive, we always want that rounded parenthesis. We could also look at compound inequalities. For instance, if we have negative 3 is less than or equal to x, which is less than 4, we can generate another number line to represent what this means visually. In this case, x has to be greater than or equal to negative 3, if we sort of read that in the opposite order. So what that means is we want a filled in circle at negative 3, and we want to shade in or indicate all values to the right of negative 3. But x is also bounded on the upper end by positive 4. So that would mean we want an open circle at positive 4, and we want to shade all values below. So what we would look for in this case would be then that bounded region between negative 3 and 4. We have a filled in circle at negative 3, since we have that or equal to statement. And then since we have a strict inequality on the upper bound, we use that open circle. Translating this into interval notation would be a closed bracket at negative 3, because again, negative 3 would make that inequality statement true, all the way up to our largest value, which would be 4, with a rounded parenthesis, because 4 would not make this inequality statement true. So we're including all values up to, but not including 4 itself. In that example, what we saw was a compound inequality where we had a strict inequality in one case, and the other case a non-strict inequality. We can also obviously end up with compound inequality statements where they're both strict inequalities, or in this case neither one is a strict inequality. And the ideas would be the same. We can even simplify our number line and just include 2 and 8 to sketch out a solution here. We know that x has to be bounded between 2 and 8, and since we have that or equal to statement, we want those filled in circles. And then we'll just shade or highlight somehow that region in between to indicate all those values between 2 and 8 are a part of our solution. Representing this in interval notation, we would use square brackets on both ends. So that interval would be square bracket 2, comma 8, and then closed off with another square bracket, which again is always linked to the idea of using filled in circles and having that less than or equal to or greater than or equal to statement, because it indicates that both 2 and 8 are values that would make this original inequality statement true.